Hello and welcome to this video. My name is Miguel, and in this video I would like to show you the debugger. The debugger is a really important tool which can be used to basically debug your application. That means to find problems or to just better understand the behavior. Therefore, I would like to show you some different techniques with our last project, the VAT calculator. You can download this project on my website devstructor.com. First of all, let's open the project and make sure that debugging is enabled. Therefore, go to Project, Project Options, Debugging, and make sure that the checkbox Generate Debugging Info is enabled. You can also use build modes. Therefore, enable build modes and click Create and Debug mode. The advantage is now that we have a mode for creating our debug executable, which will be used by ourselves, and our release executable. The release executable will be used by our friends and customers and will not include debugging information. So it will be faster and really important, it will be not so big. Okay, so let's start with the debug mode, and I would like to show you breakpoints. And breakpoint is a mark in your code which will stop your application when the mark is reached and in condition is true. To add a breakpoint, just go into your code, into a line, and press your left mouse key on the left side of the editor. This will add this red point with the question mark, and it will also change to the color of the line. And we can add more than just one breakpoint. When you start your application and the debugger is attached, the mark will change to a green arrow. I added the breakpoint in BNT add VAT, so when I press this button and this mark is reached, my application will freeze and I cannot continue using it. Moreover, Lazarus is now in my focus and I can work. So this line is now red. This means that I'm currently in this line. And now I can do some really interesting things. I can go to run, step into, step over, and step out. Step over means to go into the next line. So let's do it by pressing F8. So now we are in this line and it's red, so we are currently at this point before this line is executed. And we could now press F8 again to go into the next line. You can also move your mouse to the local variables, and this will show the value and also the declaration. So value excluded is 100, value included is 119, and last but not least, the VAT is 19. But we can also step into, therefore go to run, step into, or press F7. And now we will go into display result. That means we were at this line, and this line is now calling display result, and step into means that we jump into this procedure and can continue. So now we can continue in this procedure by pressing F8, or also go to run, step out to go back to the calling procedure. This is the basic thing that you can do with breakpoints. So you can set a breakpoint at a line, you can wait until the breakpoint is finished or reached basically, and then you can go to your application line by line to find problems. But breakpoints could be even more complex. You can also add conditions and hits. So for instance, let's add a new breakpoint, right click on it, go to breakpoint properties and set the hit count to 2. This means our application will freeze when the breakpoint hit count is 2. So 1, nothing happened, 2, and now we are back in debugging. This is really useful for loops, for instance. So if you're doing something more than one time. But you could also use conditions. Therefore, let's go to the last line, go to breakpoint properties, and let's write down a condition. For instance, value excluded should be 100. Now this breakpoint is only fired when value excluded is 100. So when it's 1000, nothing will happen, or 200, nothing will happen, but when it's 100, then our application will freeze. So we could also show some other windows. Go to View and then go to Debugger window and then Local Variables. This will show this window, and this window shows a list of all of our local variables and their values. This is really useful if you have multiple of them to better understand what is happening. For instance, we could set a breakpoint in this line and then go for it step by step, pressing F8, and then take a look at how this window changed. When you're not initializing your values, then the value could be quite confusing. So make sure to initialize all of your local variables. But we can also take a look at global variables. Therefore, we can use watches. Go to View, Debugger window, and then Watches. Oh, I have already added something. Oh, I'm sorry. Now we can go to a variable, go to Debug, and add a watch. Or maybe let's use a component like our label, debug, and then add watch. And now we can take a look at our component at any time. For instance, our value excluded is 100. You can right click on it, go to inspect and take a look. Or even our label, which is a more complex thing, is an object, and there you can take a look at all variables of this label. For instance, at the caption, which is nothing. Okay. Yeah, so this is also really useful when you are working with global variables. So when the declaration is not inside your procedure. I could show you some more advanced stuff, maybe the core stack. This is a really complex thing, so let me just show it to you. Therefore, we can take a look at display result. Not at display result, at our VAT add button. And now our core stack. This core stack basically includes all the lines of our code, so the locations, line, and the functions, and basically it's all called in a stack. It's in kind of data structure, and our application has a main loop, and this main loop called form application run and so on, run loop. And last but not least, we have the btn vet click. So it's getting more and more interesting when we do something different, when we add in breakpoint inside display result. We could use the core stack to better understand where this function or procedure is called. So let's press remove that, and now let's open our core stack. And there we can see that display result, this line is currently executed, and this line was called by the btn remove vet click procedure. Therefore, you can also go to view source, and this line currently executed display result. So the call stack is a more complex thing and can be used to better understand where something is called. Here there are more basic debug windows, threads, but we did not work with threads, or something like the assembler, which includes the current code line and the assembler calls. But I think the functions, or basically functionalities I showed, are the most important ones. But I would also like to show you the influence of our executable size. So let's compile our application. And this application has a size of, okay, this is not fair because it's separated. We have a debug file and the application, but you can also put both into one file. Use external debug symbols file. So now both files are in the executable. I can delete this file. This executable is nearly 15 megabytes big, and this is really big for an application that does basically nothing. The reason for this is that this application includes all the debugger symbols which were used by us to better understand it. It also shows memory leaks, and this is something that we do not want in our final application. To disable memory leaks, you can go into the build mode and then disable check for memory leaks. But we can even do it better by going into the release mode and then compile our application for the release. So this application will be used by our customers and friends, and it's only something like 1.75 megabytes big. So this is the application you want to send as an email or put on a USB drive. Memory leaks are something useful. Basically, I could tell you that it should be, when you stop your application, all your allocated blocks should be freed. So you should have 0 unfreed memory blocks. If you're not doing this, like you're doing something, let me just do something bad, then this message will have a different content like this. We have 12 unfreed memory blocks, and then you should find this problem and also of course correct it, because a memory leak could be really a serious problem. Even more when your application runs all the time and it's allocating more and more memory until the application or the computer crashes or is getting too slow. This topic, so using the debugger, is really important but also a bit complex, and I hope that you understood what I showed. When something is not working correctly, you could try to use the debugger and basically try to observe the behavior of your application to understand the problem and be able to correct it. Okay, see you in the next video. Bye.